Okay, so welcome to today's Gardener review meeting. Raphael is having some technical difficulties, therefore I will moderate today's occurrence. We will focus on the 1.119 release. First, we have four sections planned today. First, we start with some security-related topics, which Tim will present. Then Shafiq will talk about forceful redeployment of gardenlets. Hopefully, until then, Raphael has controlled his system and can show a little bit the progress of GAP28, so gardenadm token and gardenadm join. And last but not least, I will give a short demo of the new kube-proxy readiness probe. So without further ado, I would like to hand it over to Tim. If he's in the meeting, he was in the meeting just a second ago. Tim. We can't hear you, Tim. Can anyone hear me?
Yes, we can hear you.
Yes.
Maybe Tim has some connectivity issues. Tim, you're back?
Yeah, I'm back. Sorry about that.
Okay.
Seems like Raphael isn't the only one with technical issues here.
Okay.
Okay, 1 second. All right. So, we wanted to use this slot of the review meeting to, as a little reminder that there are newly published CVEs that affect Gardener. And this is your call to action, or our call to action for you, because all of the CVEs that I will present have a base score of 9.9. At the same time, I'd like to mention that we don't want to use this slot to reveal any technical details or more information about the vulnerabilities themselves, also for your protection. So we don't want to do that right now. And we also want to ask you to refrain raising any questions after the presentation. We're happy to take them offline, but probably not in this round. Okay, so I think this will be a really quick one. So the first CVE is affecting not the core gardener, but the external DNS management component. And especially if you use that in combination with GCP. So there can be a privilege escalation in that combination, and we have a fixed version of that. So if you are affected by this kind of setup in your landscape, please update to at least that version. So then everything will be good. The second CVE is affecting the core gardener. It's that under some circumstances you can bypass the cloud secret validation, and this can again cause under some circumstances to privilege escalation. We have a few fixed versions for that as well. You can see them on the slides, so also please update to those versions depending on which minor version you are with your gardener to ensure you're not vulnerable anymore. And the last CVE is also like a privilege escalations, but this time with metadata injection from outside. And the fixed versions are the very same. 2 more sentences I would like to mention or say is that all of the CVEs, they affect a setup where users are already authenticated against the gardener or the garden cluster. So it is nothing related to any unauthenticated requests. And also this is the result of our very own findings. So we strive for testing our systems continuously at SAP. and we don't want to hide anything. So we came up with these action items and took the process very seriously in order to protect you as a community member, but of course also ourselves. Okay, with that being said, again, please update, and back to you, Johannes.
Then let's hand it over to Shafiq.
Hello, everyone. So I hope you can hear me, but yeah, today
Yes.
I'll be presenting this PR, which is about Gardener operator forcefully redeploying gardenlets on demand. So to give some context, so we had introduced this gardenlet resource in the seed management API some time ago. This was to upgrade gardenlets in unmanaged seeds, so which are not having a managed seed resource and no shoot cluster behind. So we had to regularly deploy the Helm chart for upgrading them. And if the cluster is behind a firewall or is in a restricted environment, this can be tough. So we introduced this gardenlet resource. So in gardenlet itself, there is a controller which watches for this resource. And if there is some change, then it will upgrade itself. So kind of self-upgrade. So, and if you deploy the gardenlet resource, then Gardener operator will take care of the very first deployment. So it will apply all the charts and everything. And then after that, it is the responsibility of the gardenlet to upgrade itself. So Gardener operator has no role after that. So just in case, if we need a forceful redeployment, let's say a client certificate has expired or you face some issue in gardenlet and the first action was to get rid of the deployment or the pod, thinking that operator will recreate it and it doesn't, then you are in trouble. So for that, we had introduced this annotation, so which tells the operator to redeploy the charts again. So I have prepared a very short demo also. So I have a garden here. Also, there is a seed and a gardenlet is running. And if I go and delete the gardenlet deployment, then then there is nobody watching for this gardenlet resource, and then seed will be in unknown state and you'll be in trouble. So that's when the new annotation comes into help. So if I now annotate the gardenlet resource with the force redeploy annotation, then we can see that the operator again comes into play and deploys the gardenlet into the cluster. And we can see that the deployment and the pods are back. So yeah, that's pretty much it. Back to you, Johannes.
Thanks, Shafiq. That's really a nice improvement if something goes wrong. Then let's try to hand it over to Raphael. Let's see if the system works now for the gap 28 improvement.
Thank you. You can hear me all right?
Yes.
So I would like to give an update about the state of gap 28, the autonomous shoot clusters. I think the last time we had this topic was about more than a month ago. And yeah, meanwhile, we have made some more progress on it. Let me jump directly into the system. So what I have done up front was to basically start the local setup and then exec into the machine pod here and run gardenadm init with a path to a directory which contains all the resources like the shoot manifest and so on. I think this is also what you have seen last time. And then it starts to deploy a lot of things. And meanwhile, we have reached a state that we actually have a ready node here. I think in the last presentation, we were at the step where the CNI was missing. And yeah, now we have everything deployed basically. So there is the Calico, gardenlets, and kube-proxy. And we actually have also deployed a few more things already. So if we take a look at the pod ranges, then you can see that 10.1 is basically the host or node network, and 10.3 is the pod network. And also looking at the extensions, we already have deployed everything properly into the pod network. So the CNI part is working as expected. The proxy is here. And we do that with the help of the existing code. So we have this network resource here, which got reconciled by the Calico extension, and then Calico got deployed just like it happens in regular shoots. And we also have a control plane extension resource, which leads to the deployment of this local path provision for the local scenario. And we also have enabled the webhooks that extension basically can have. So provider extensions may modify the deployment of Kube API server or Kube controller manager or Kube scheduler or whatever. And this is also working in the local setup without actually changing the extensions. So if we look at this Kube scheduler, which is here in the scenario static pod, we can see that it has a label somewhere, this one, which is basically injected by the provider local extension via a webhook. So this mechanism works basically out of the box, and transporting these changes into the static pod manifest is also working. Okay, so this is the current state. We also have deployed etcd Druid already, but you can see that the two etcd pods that we use here are still the so-called bootstrap etcds, meaning they don't have a backup sidecar or any more sophisticated configuration that we are used to for regular shoots. So they are just minimal etcd deployments to get the whole process up and running. And the goal would be that once etcd Druid is capable of doing so, to replace these two pods with pods managed by the etcd Druid. So this is basically not yet there, but we have already made some preparations. So we have already created a backup bucket resource and also a backup entry resource. So these things are also ready. And yeah, as I said, once etcd Druid has the needed changes, then we can also switch the etcds to put them under control of the Druid. All right, then otherwise, we have worked on making it possible to join worker nodes. So this here is just a control plane node. Just to recap, we have this one node here. And now you would like to join a worker node. And for this, there's also this gardenadm token command, which is similar to kube-adm token if you're familiar with it. So it is used for managing bootstrap tokens that later can be used for the gardenadm join command. So when you want to join a node, just like it happens for regular shoots, you need a bootstrap token that is used to bootstrap the whole process, fetch a real token or a real certificate, and then download the configuration from the API server that should be applied to the node. Yeah, and with this command, we can basically do a few things. We can list all the tokens. So this here is, for example, the one that we used for the kubelet of the control plane node. You can see it is expiring in a minute or so. Then you can generate a completely new random token. So this is just generating it, but not creating it on the server yet. You can do so by, for example, copying it like this, creating it. If you then list it, then you can also see it here. The default expiration is 1 hour. You can change it via flex. Or if you just want to directly create a random token without having this two-step process, running generate first, then copying the token to the create command, you can also do that, which would also generate a random token and directly create it on the server. And then there's also delete, to just delete one token. And what else do we have here for the create? I think this is also in kube-adm. So for convenience, you can basically specify this flag, #print join command. And if you do that, then you will not see the token here as return value, but the full gardenadm join command that you can just copy on the node you want to join to the cluster and run it there, and then it just joins. So let's do that. Here's the command. We basically have a bootstrap token. Yeah, a little bit clumpy, I would say. So the CA certificate bundle is also here. We might improve that in the future, but for now it's part of the command. Then the name of the secret for the Gardener node agent, which basically contains the operating system config and the address of the control plane. And that's already it. So we copy that and switch to the second tab. So here I'm on machine 0, which is the control plane. Here's machine 1. That's basically an empty machine. I copy the command, run it. It's already done. So what it basically does is, like for regular shoots, it starts this Gardener node init systemd service, which downloads the Gardener node agent binary from the image. And then Gardener node agent comes up. It downloads the operating system config from the secret using the bootstrap token and sets up all the needed other systemd services that we have, kubelet and whatnot. And that's already it. If we go back to the control plane node, we can check the nodes. And there's machine 1, which is currently joining. If we look at the pods, Calico is currently initializing. kube-proxy is already running here on this worker machine pool. And now you can also basically directly delete this bootstrap token that we used for joining this node. But it will also be automatically deleted after the expiration time is hit. We can do it maybe. So this D7, whatever, is gone now. And you actually can also call the delete with just, for example, the token ID like this. So you don't have to specify the full token with a secret also in it. Or you can specify the name of the secret like this with bootstrap token prefix, and it will all work and delete all the resources. So node should be ready now. Yeah, value goes up, and we have a worker node in the cluster. So that's the current state of the, let's say, high-touch case, where you basically just start from an existing machine, however it got created. Might be a bare metal machine or manually set up VM or whatever. The next steps here are, as said, to wait for etcd druid to be ready and then switch the etcd resource to replace this bootstrap etcd. We also have a few minor additional changes here coming up in the extensions also. And then the next big part would be to also support joining additional control plane nodes. So for now, we can only join worker nodes. But of course, for productive setups, we want to have HA control plane nodes with the etcd cluster and so on. So this will be then the next big part. And in parallel, the work also started on gardenadm bootstrap. As you can see here, I will not go into the details now, but perhaps we can see a demo in one of the future review meetings also for this part. Okay, that's it. Any questions to it? Then thanks, and back to Johannes.
Okay, thank you, Raphael, for the nice presentation. Then let's move over to the last topic of today, the change in the kube-proxy readiness probes. So I'm presenting this change here. We can also take a look at what was actually changed in the source. It's really, really not a lot. So I can directly show the demo, but I think it makes sense to understand what we are talking here about, because basically we're changing the readiness probes from /health to mostly /lives, except for older releases where that is not available yet. So why did we actually need to have this change? So this change is basically a result of some improvements on kube-proxy with 1.28. And that's here the pull request in upstream, kube-proxy improved ingress connectivity reliability, and also here's a corresponding cap. So if you want to read about it, here you find all the details. But let's give you a short summary. It's mostly about load balancer services with external traffic policy local. So let's take a short recap. What does that mean? As you may know, Kubernetes supports load balancers on the different infrastructures, and with load balancers, you have kind of two options with load balancer services. You can specify the external traffic policy, and I did an error here. We're talking about cluster, not local. So you can, per default, you have external traffic policy cluster, and you can also specify external traffic policy local. So external traffic policy local means the load balancer will only forward traffic to nodes that also have a backend on the node. With external traffic policy cluster, the default load balancer will effectively send traffic to any node, and then from the node there is, for example, kube-proxy or any other service routing component running that then will forward the traffic to one of the replicas. This means, in effect, you see here basically two traffic flows, one in green and one in orange or yellow, where basically one client goes to a load balancer, the load balancer forwards to node 1 in this example, and then the IP tables rule for kube-proxy basically sees, okay, there is a pod replica on that node, let's directly forward it there. And the second flow is basically a different client, or maybe the same client with another connection, goes to the load balancer, and this time the load balancer just decides for whatever reason to forward it to node 1, where there is no replica running, but the kube-proxy or service routing component will then simply via additional load balancing basically decide, okay, which replica I should send it to, and in this case it will send it to another node, to the replica 1 on node 2 basically. So what we can see for that is basically regardless where the load balancer will put the traffic on any node, it will end up on one replica. So I'm not going to discuss all the advantages and disadvantages of external traffic policy cluster, but just this kube-proxy enhancement tackles one scenario, because that is quite important for Kubernetes, because as you know, Kubernetes is usually not as static as we see it here on the picture. There are not a static number of nodes, there are not a static number of pods. And in particular, what this enhancement tries to address is basically the dynamic node handling. Because if we have different workloads, if we have a component like cluster autoscaler or something similar there, then clusters may scale up, which is fairly easy. Okay, load balancer need to send traffic to a new node, but clusters may also scale down. So for example, node 1 might go, it might not go down, it might be actually removed by cluster autoscaler, because in this example we see there is no pod running, so we could simply remove it. However, if we have, for example, a long running connection here, the yellow-orange one, and we remove this node, then effectively this connection will break, because the load balancer will try to continue to forward traffic to node 1, and if that's gone, it will not be able to forward to node 2 to the actual pod. Now for existing connections, there is nothing we can do about it, because we cannot reschedule kind of the connection once it's established. That's all happening during establishment. But for new connection, we can change that. And especially with scale down, cluster autoscaler does not simply delete nodes. It first drains the nodes. And draining nodes can take some time. So it can take time until all the pods from the node to be deleted will actually be moved to another node. And during that time frame, we don't want new connections to actually go through to that node. And that's basically what the upstream pull request tries to do. It's basically once a node has been deemed or decided to be removed by cluster autoscaler, which in that particular case is decided on via a node taint, then no new connections should go to that node with external traffic policy cluster, because soon that node will be gone. The implementation in the upstream Kubernetes does that via a new endpoint or via the old endpoint health, and taking into account the node taint. And thereby the health endpoint will report failure so that the health check, the load balancer will do health checks on all the nodes, that the health check for the load balancer can fail. Just an important note, this health check, so the kube-proxy health endpoint is not necessarily used by load balancer. So in the infrastructures we support, it is used on GCP. On all other infrastructures, usually the health check for external traffic policy cluster ports is the node port, which does not help in this scenario. But anyway, let's see that in action. It's a small showcase. We have basically here two clusters. On the right side, we have a local setup with 118, and on the left side, we have a local cluster with 119. And in both cases, we have a chute in the local setup with two nodes. We see here also the kube-proxies. And now what we can do is basically we simulate cluster autoscaling removal by simply patching the node resource and adding the to be deleted by cluster autoscaler taint. And if we if we add the real node name, of course, then it can work. Then we add that basically on both sides. Here the node is named differently. So we have now patched the first node on both clusters to be deleted by a cluster autoscaler. Now what happens is basically kube-proxy will eventually, as we see here, in the old cluster, because there we use the health endpoint as a readiness probe, it will report being not ready. In the new cluster, in the new Gardener release, this will not happen because we use the live endpoint instead. Why is that relevant? Because these readiness checks are actually part of the system components check. So meaning that now the system components got unhealthy, and if we would use the dashboard, we would also see that. We can also try to forward basically to the kube-proxy port and see what that actually means. So if we now we forward basically to the port that kube-proxy is reporting on, and if we check the health endpoint in both clusters, we see basically that on both clusters, the health is actually reporting 503, so service unavailable, because we have the cluster autoscaler taint there. But the new with 128 added live endpoint of kube-proxy is actually for both of them reporting 200. And because we switched basically the readiness probe for kube-proxy from health to live for newer clusters, kube-proxy stays ready, and we don't see the system component being unhealthy. So why is that at all relevant? Because if you have clusters with nodes where scaling down takes a longer period of time, for previous to that change, you would see system components becoming unhealthy just for nodes that have cluster autoscaler taint on them. And that can be an annoyance or in general a problem for operations team if you just see clusters that seem to be not healthy because kube-proxy is not healthy, but that's just a intermediate state of affairs until cluster autoscaler actually scales down the node. And if you have, depending on the workload, pod disruption budgets, termination grace periods that are long, and so on, this can actually be a long period of time and therefore quite annoying for operations teams. Okay, and that is now fixed in the new version. So that's all for this part. Any questions? Otherwise, I hand over back to myself and thank all presenters for presenting, and thank you for joining, and have a nice day. See you soon.
See you.
Bye-bye.
Bye.
Bye. Have a good day.
Bye.
Thank you.